So there's been some requests for some extra practice problems and maybe even a little video tutorial. So I'm going to try to kill two birds with one stone in that regard. So what we're going to do is these are problems you've not seen yet. And there's one of each kind of type from that second chem quest. The first one will be a boiling point, freezing point type question. The second one will be a vapor pressure type question. All right. Now, what I'm going to recommend is that you guys have your notebooks with you right now, your calculators, etc., and a sheet that has formulas on it. So that quiz number 2 that we just took Friday, May 22nd, would be your best option for that formula sheet. And then maybe you just read the question up there on the board, hit pause, and see how much you can do by yourself. All right, and then you can kind of watch me walk through the problem if you get stuck, or just to check your work, and you can fast forward, rewind, all that kind of stuff. But do try to do this yourself, right, before, and then you can kind of see where you're getting stuck, if you're getting stuck. Now, I didn't have space to put formulas up here, and so I think that's important. You guys are able to refer to the formulas that I talk about before I put them up here, okay? So, without further ado, I'm going to go ahead and start tackling our first question. So, I'm going to add 27.4 grams of an unknown covalent solute to 250.0 grams of water. Boiling point of the solution is 102.4. So this is a boiling point question. So that right there tells me I'm going to be using my delta T BP formula at some point during this process. Okay, so the letter A says to find the molality. All right, so normally we find molality by going moles of solute over kilograms of solvent to find molality. Now, we don't know how many moles of solute we have, all right? But luckily, we do have a formula that allows us to find that molality because we do know the boiling point. So I'm going to find that formula on my quiz too. Oh, there it is. So letter A, I'm going to use my delta T BP equals molality total times my boiling point constant, which would be KBP. Right? So again, you'll see this formula on your test or quiz. Alright? So I'm going to fill my values. I know my boiling point is 102.4, so my change, okay, in boiling point is 2.4 degrees Celsius. Alright? And that's going to be equal to my molality, which I don't know yet, times 0.515, which is that boiling point constant for water. Right? And then I solve for my molality and I get 4.66 equals empty. That's my molality. So letter A, done. Alright, so now I know one more bit of information about what's going on up here, and that is my molality. Alright, so now that I know boiling point and the mass of my covalent solute, I also know the molality of my covalent solute, which is useful for step B, because I'm going to use that molality plus other information I know to come up with my moles of solute. All right? So, molality is, right, so if you remember, molality is equal to moles per kilogram of solvent, right? And this would be moles of solute. When we talked a fair amount about that in the last video I posted here. So moles of solute over kilograms of solvent is what molality is. So I'm going to write this out. Moles solute over kilograms solvent equals molality, right? And so here I'm trying to find moles of solute. Alright, so what I can solve for now is moles of solute because I know my molality and I know my kilograms of solvent. So I'm going to solve. This would be my x. So I can write this like x over a kilogram of solvent would be this number in kilograms. So that's 0.2500. So x over 0.25 equals 4.66. Alright, so I just multiply both sides at 0.25 and x will come out to 1.17 again, as you guys are trying to figure out what formula to use, what you have to do is look at your list of formulas that you're given, right? Identify which formulas have the variable you're trying to solve for. So again, we're trying to solve for moles of solute, like it asks us to do in part B, right? So I'm going to look for a formula that has moles of solute as part of that formula. There might be a selection of those. So then, once I found those formulas, I look at, okay, what information do I have, and which formula can I fill in values for, all right? And that leaves you with the molality formula, all right? Now for step C, I'm going to write it over here, where I've got some more space. We're going to calculate the molar mass of my solid, all right? So this is a formula I'm not going to give you because all of you should know how to find mass, molar mass, and moles, all right? So it's mass of over molar mass equals moles, right? So again, I want to find molar mass. This molar mass is going to be my unknown value. That's my x, right? But I know my mass because it's given to me up here in the question. That's 27.4 grams. I know my moles because it's just solved for it in step B. All right? So I'm going to fill in this value and this value. So I've got 27.4 grams over x, which is my molar mass, equals 1.17. All right? And a little algebra trick. I flip-flop my 1.17 and my x and divide, and I get x equals 23.4 grams per mole. All right? And that's a pretty typical problem set you're going to see on your test on Wednesday, next Wednesday, okay? Obviously, just be different numbers, but the same process, right? So the idea is, from your list of formulas, can you figure out what you're trying to find, and which formula is going to help you get that value based on what information you're given, all right? So that's where the practice comes in and the reviewing, all right? So that being said, we're going to go ahead and move on to the next problem set. I'm just going to slide this board here, this board there, shove in my mess of papers. There we go. And so for this question, it is a vapor pressure question, 2.30 kPa, 1.80 kPa, vapor pressure. Right? So again, because I see it's a vapor pressure question, I know that I'm going to be involving my mole fraction, right? So if you look up at your list of formulas, you'll see two formulas that have the mole fraction symbol, which is the X solvent, right? So how do you know which ones to use? Again, that comes down to what information am I given in the question. In this case, you are given pressures and masses, right? So there is one of those two formulas has pressures in it, so I'm likely going to use that one. So for letter A here, to do my first step to calculate my mole fraction of water, I'm going to use my P solution equals X solvent, right, which is my mole fraction, times my P solvent. Alright, so I've got two vapor pressures up here, and I've got two pressures here, just knowing which one to put where. And as you all have memorized, I'm sure, that when you add a solute, the pressure goes down. So the pressure of the solution will always be less than the pressure of the solvent. So I'm going to pick my lesser value from up here, which is 1.8. So this is 1.8 kPa equals X solvent, which is my unknown value at this point, times 2.30 kPa. Okay? And simple, divide both sides by 2.30, I will get 0.783 equals X solvent. So my mole fraction is 0.783. And that's dimensionless, it's just a factor we're multiplying by. Alright, so I know my mole fraction. Now letter B says calculate moles of water, and that is an easy calculation. You don't need to look at your formula sheet for that. It's just mass of water over the molar mass of water. And I know my mass of water is 295.0 grams, H2O, over 18.02 grams per mole, right? That's the molar mass of water, which is helpful to memorize, by the way, right? And simple division gives me 16.37 moles of water. Okay, so I know 2 bits of information now. I know my mole fraction of water, and I know how many moles of water I have. All right? So now I know moles of solute. All right, so again, I'm going to go up to my formula list. I'm going to look for a list, the formula that can be filled in with the information I have, and also has something about moles of solute in it. All right, and you will find that with the information here, I have moles of solvent, and I have mole fraction of solvent. There is a formula that has moles of solute in it, and those things in it. So now we can just fill in values, again, solve for it. So letter C, I'm going to use my mole fraction formula, which is X solvent is equal to moles of solvent over moles of solvent plus moles solute. All right? So I know my mole fraction of solvent, I know my moles of solvent. So I know of those 4 values, I know 3 of them, which makes it pretty easy to solve for just one. So my X solvent, 0.783. Moles of solvent, 16.37 over 16.37 plus X in that case. We're just putting X in there for moles of solvent, right? So again, simple algebra trick. When my X is on the denominator side or on the bottom of that fraction, I can flip-flop my values. So I'm going to rewrite this equation. So 16.37 plus X equals 16.37 over 0.783. All right? So I would divide those values and then subtract 16.37 from both sides. Now we'll get X equals 4.54 moles of solute. All right? So now I know my moles of solute, and what I'm trying to eventually get to is my molar mass of solute, right? So I had to find out a little more information about my solvent first, right? To figure out the information about my solute that was missing to be able to find my molar mass, right? So now I know moles of solute, and I know my mass of solute, so I can find my molar mass. Pretty simple. I'm going to have to erase some items to make space for this stuff. All right? So I'm going to leave my 4.54 moles of solute there, so I don't forget that number when I'm setting up my next equation, right? And so mass, molar mass, moles. It's that equation, which again, you guys shouldn't have to think too hard about at this point in the game. This late in your chemistry career, that should be boom. Got it, got it, got it. So I want to find molar mass. I know my moles of solute. I know my mass of solute. So remember, mass over molar mass equals moles, right? That's that instant recall equation. I know my moles, 4.54, which I just found. I know my mass because Mr. Huberberg told me that was the mass in the question. Right? What I don't know is my molar mass. That's my X, right? So, algebra trick, flip-flop, the denominator, right? So we're going to go 98.3 over 4.54 equals X, right? Just switching those. That only works when X is on the bottom of the fraction, by the way. Okay, and so X will be equal to 21.7 grams per mole. Right? And all she wrote. That's what you guys are going to see from ChemQuest 41 on your test, right? Not the exact same question, of course, but similar. All right. So hopefully you guys did take my recommendation and you tried to solve the problems before I walked through them with you. These are 2 extra problems, and I'll have some more for you Tuesday after Memorial Day. So hopefully you guys watched this over the weekend and didn't take the 3-day weekend to forget all that hard work we've been doing. Keep at it. Test Wednesday. You can run, but you can't hide.